right. So did anybody have any issues finding the calculator? You had an issue? You weren't able to find it? Where'd you look?
I went to Target and you did went to Walmart?
Really?
Yes.
Nothing like this there? Yeah, do you shop online?
Yes, I think I'll get it.
Try it. You don't need it right away, but for the first test, you'll want to have it. Let me know if you continue to have issues.
Yeah, I went to Target too. There was a spot for it and they were just sold out. So
Sold out.
So
Okay. Okay. All right, well, make sure you try and get this by the first test. And let's get going. So, word problems, right? Fractions, we were doing operations with fractions last time. And we stopped, I believe, on just at number 17, right? Yeah, we didn't. Oh, wait a minute. Is this the homework? Oh, that's the homework. We stopped with Dolores and her candy, right? So I'm not going to work through all of these, all right? I'm just going to work through a few. So let's just kind of get warmed up here. I'm going to do this first one, number 12. Can everyone see this reasonably well? Remember, you can print all this stuff or you can print it or buy it at the bookstore. You got that? Okay. Thank you, Diego. All right, so in language arts class, the class was asked to write a team paper. Each team was to write 5.5 pages for the combined paper. When all the teams put their papers together, there were a total of 44 pages. How many teams had worked on this paper? Happy Monday. We get to start with math, right? So any ideas on how to approach this? I'll take volunteers here. Yes?
Well, what I did was I just put 5 into 44.
You divided this into this? Yes? Okay. Let me give you a suggestion for word problems for the future, all right? What I think gets people in trouble a lot of times in word problems are the numbers, and it confuses them. So what I'm going to do is you are correct, but let me just show you. If I change this to, let's just say 5 pages, and let's change this 44 to maybe like, I don't know, 40, okay? Then reread the problem to yourself. You know, they need to write a paper. Each team had to write 5 pages, and at the end, there were a total of 40 pages. How many teams had worked on the paper? Does the math seem easier to you if you look at it that way, yes or no? Yes? Because what's the answer going to be? 8. So you need to ask yourself, how did you get 8 from that? Well, you just take 40 and divide it by 5, right? I suggest that you do that with word problems when you're getting stumped. Just change the numbers to numbers that make a little more sense to you, and then you can almost like automatically, a lot of the times, figure out what the operation is, and then you can just change everything back to the numbers they gave you and do the operation. So we are basically in this problem, if we left it as 40 and 5, we are doing 40, and we are dividing it by 5, right? That's what we're doing to get 8. But instead of using 40 and 5, I'm going to be using 44 divided by 5.5. Okay. So to do this again, since this is a warm-up, we just got here, right? It's Monday. I'm going to walk us through this. What I would do first is I would change this problem into, I would change the 5.5 over to a, what did we call that again? This is a mixed number. Change it into an improper fraction. So that's where you multiply 5 times 2, which is 10. Add 1, you get 11 over 2. All right. And now I'm going to realize, I guess I could put equals here. I'm going to realize that 44 is the same as 44 over 1. Okay. And so I have a fraction divided by a fraction. How do we do division of 2 fractions? You change it into multiplication, and you flip over the, which one do you flip? The second one, right? So this is going to become 44 over 1 times 2 over 11. And now how do we multiply fractions? Just straight across, right? So this would become 44 times 2, so 88 over 11. And if you divide that pretty clear? Yes? What is this? 8. So you have 8 teams. Okay? All right, let's look at the next one. Dennis's new dog weighs 127 3/4 pounds. His friend's dog weighs 94.5 pounds. That's a big dog, right? How much more does Dennis's dog weigh than his friend's dog? So again, can I just show you the changing of the numbers real quick just to see what I meant by that? Let's just say this dog weighed 130 pounds instead. And let's say this dog weighed 100 pounds. How much more does Dennis's dog weigh than his friend's dog? So what would the answer be there? 30. So what did you do to get 30? Subtracted, right? 130 minus 100. So I hope that helps. I mean, honestly, I still use that sometimes just to get a quick idea of what the operation is. So I'm going to be needing to do 127 3/4 minus 94.5. I'm sorry, I'm all kind of, I don't know, I think it's allergies. I feel fine, but I sound terrible. Okay? Same story here, right? We can switch this over to improper fractions. Someone asked, I think last class, about leaving it. Who asked? Was that you?
Yeah.
Yes, okay. We can do that. Like you can just do 127 minus 94 and do 3/4 minus a half. That is fine if you do it that way. But I was stating that it's a little dangerous sometimes. Like if this was 1/2 and that was 3/4, then it becomes problematic. But I think for this one, should I just let you handle this one on your own? You know, you think you can do that? Switch it over to improper fractions and then combined, or should I do it? Okay. Please raise your hand. Don't yell out like that, please. Do you want me to do it or not? Yes? Okay. All right. So I'm going to multiply. So I might need my calculator here. 127 times 4, and then add 3. What is it? 511 over what? 4, and then minus, and then 94 times 2, 188, and then add 1, right? So 189 over 2. So this 511 was this times this plus 3, right? Okay. And now I need to subtract. So what's the thing about subtracting? You can't just do this unless what? Same denominators, and they don't have the same denominator. So we say, okay, what would be a common, least common denominator between those two? We'd need a 4, right? So to make this 2 a 4, well, I don't have to do anything because that's already 4, but to make that 2 a 4, I have to multiply the top and the bottom of that fraction only by 2, 2 over 2. So that would become 511 over 4 minus, what do we have here? 378 over 4? I'm sorry?
Yes.
Yes? Okay, thank you. So multiply across here, we get this. And now that they have the same denominator, we can just subtract the numerator. So what's 511 minus that? 133? Okay. So this is the answer as an improper fraction. Now, I would accept that on a test. However, if you're asking how much more does that dog weigh, 133/4 pounds is not something that you can really, I do this sometimes when I feel like messing with people. Like I'll go, like if you've ever bought like deli meat from Home Depot, not Home Depot, sorry. If you bought deli meat from Home Depot, it probably tastes terrible. From H-E-B or something, and I'll go and I'll ask for like 5/4 of a pound, like 5 over 4, right? Which is really like 1 1/4 pounds. And they'll just be like, what, You can give improper fractions. They're still the same thing, but let's get it to something that makes a little more sense to us. So how would I change this back to a mixed number? Divide, right? So I'd have to actually do the old school division like this, and then go through that little thing, right? So does 4 go into 1? No. Does 4 go into 13? Yes. How many times? 3 times, and then you bring down, you multiply. I'm assuming you can do this. Okay, so if you can't, that's okay, but you need to like go get help or come to my office, something like that. Okay, then here we have 1, 13 left over again, and then 4 goes in 13 again 3 times. And multiply, you get 12, and then 1 left over, and then that's your remainder. So you get 33, and then your remainder over your divisor 4. So 33¼ pounds. I think the shorter way to just do 127 minus 94, and then 3/4 minus a half would definitely be faster. However, again, it can be dangerous if this was 3/4 and that was 1/2. All right. Let's do 14. We'll make 14 our last one. So everybody read that because I'm going to call on somebody, but I'm going to let everyone read it first. There we go. Still seems too quiet in here. Yes?
Well, no, we just did. If you
Uh-huh.
do it with the calculator and it's 33.25, we
Uh-huh.
can set that on the test.
Okay, so the question was whether or not I would accept a decimal answer off of your calculator for the test. For this first test, I want to make sure that you can do operations on fractions without a calculator. So you can use the calculator to check your answer, but I'd like to see you, get common denominators and do that. All right, everybody read it. Are there any questions over the question before I call on somebody? We should just call on Diego because he wasn't here. No, I won't do that to you. You got called last time, right? See, so you can just chill out. Is it Adriana? Hi. You got lucky here. So, do you have any questions over the question? Do you have an idea of how to do it?
Subtraction.
Pardon?
So the subtraction?
Subtraction? Okay, I don't know. I haven't read the problem. On their vacation last summer, pacing a third of a gallon. On their return trip, how many miles per gallon did they get on their way out of town, on their way home? Okay, so just subtraction. Let's see if take a vote. How many of you agree with that? Subtraction? That looks like you're probably right. Which one are you going to subtract? So one of them goes first, one of them goes second. So which one are you going to put first?
30 and 1/2.
Okay, good. So 30½ minus 17 7/8. Okay, are there any questions on how that was interpreted by Adriana? By the way, if you have a nickname or anything else you want me to call you, let me know so I can change it on the stick, all right? Any questions on why we're doing this operation? It wants to know how many more miles, right? How many more miles? So it is a difference between two things. And then it was how many more miles per gallon of fuel did they get on their way out versus on their way home. On their way out, they got 30½. On their way home, they got 17 7/8. So we do that subtraction, and that'd be it. So do you want me to do this one, or can I leave it? Again, please, show me the respect of at least raising your hand. No yelling. Yes or no? It's you. It's your, yes.
Yeah, I was thinking we had to, well, in my opinion, it's safe to switch to like the mixed number to improper fraction to subtract.
You want to do improper and subtract?
Yep.
We actually have to do something because this is a problem where you have 1/2 is smaller than 7/8. So if you try and just do 30 minus 17 and then do this minus this, you're going to run into some issues. This is one of those ones. Let me just work it. Okay, what is this as an improper? 61 over 2. And Liliana, what is this one as an improper? 143 over 8. Okay, now we're going to start rolling with these sticks. Joseph, where's Joseph? Okay, we get to save him then. And is it Uriel? Did I say that right? No? Did I pronounce your name correctly? Okay. I was going to ask you what you would do next. Do you, common denominator, which in this case would be what? 8. So in order to get 8, I'm not going to have to touch this at all, right? So what am I going to have to do with this one? 4 on top and bottom. Okay, great. Everyone good with that? Okay, so hit that with the 4 on the top and the bottom. Like that. And then our new fraction, that new fraction on the left, Melissa, where's Melissa? Do you have this yet? This fraction, what this is going to become? 244 over 8. And then still minus 143 over 8. All right. Did you already do that? You want to just finish it? 101 over 8. Okay, good. So that's your mixed number. That's your improper fraction answer. We'll get it back. Let's just take it back to a mixed number just to finish it out. So if I'm going to do 101 divided by 8, 8 goes into 10 one time. Subtract. I have 21 left over. 8 goes into 21 twice. That's 16, and we'll have, subtract, we'll have, what's that, 5 left over? So our final result here is 12 and 5/8. 12 and 5/8. And then you should put it, I haven't been doing it, but you should be putting like miles per gallon. Okay, that is it. Let's proceed on to the next section. So the homework assignments now, you should be able to handle, for the most part, everything from page 7 and 8, I believe it is. You might run into some issues on those homework word problems. And if you do, then next class I'll answer questions at the beginning. Remember, the answers to these are posted online. All right, so now we move on to order of operations. And I ended class, remember I ended class with that problem? We took a vote. It was like something divided by something times something. Like half the class was either taught the wrong way or remembered it wrong, right? Remember that? Okay, so we are going to talk about order of operations. And I am going to review what the proper procedure is. So I do still recommend we follow this Pemdas thing. And what this means is that when you look at an expression, you're going to do an operation. Okay, so like only one operation. You do, like whatever we're going to do one operation, we have to follow that. After we do that operation, we start over at the top of this list, run through it again, do a second operation. And then we repeat, go back to the top of the list and keep going. So every single time you do an operation, you have to refer back to that list and you have to start at the top. So what does the P stand for? Parentheses, I'm not going to write this down. Parentheses always go first. You do what's inside of parentheses first. E, exponents, those are the powers up on top. You do that next. Multiplication and division, but remember these are equivalent. So you do these left to right. The way they appear, right? The way that they appear in the expression, you work from left to right, doing whichever appears first. So it's never multiplication before division unless it's to the left of it. And then addition and subtraction is also done left to right. Okay, so let's take a look at this first problem here. Number 1. Diego. So Diego, what would your first operation be for number 1? Do the 10 minus 2. Right, everyone? We're doing what's in parentheses first. All right, Diego, I'm going to write that down. So this is going to be 5 minus 3 plus 72. Now what do I write next, Diego? I mean, you told me what to do, 10 minus 2, which is 8, right? So how do you want me to write that 8? So you want to keep a parentheses there? Okay, so if I keep the parentheses here, that's just 8. That's fine. That is okay to write it that way, right? What's important is for you to understand that there's nothing else you can do inside here, right? So if I start over right now, and I start a parentheses, there's nothing I can do inside that parentheses because it's an 8, right? And it's also important to understand what the operation is between these two. So what is the operation happening between those two? It's implied that it's multiplication. So you can leave that just like that, and everyone should understand that that was multiplication. Or, Diego, you could also have just put a dot next to the 8, and it would be understood that it's the same thing. So either way, I'm just showing you both ways, okay? I'm going to leave it as a dot, if that's okay. Now, Anna Estrada? Where's Anna? Okay. Anna, what would be our next?
72 times 8 comes out to 576.
576? Okay, so we're doing multiplication next. 576. Everyone agree? We had subtraction, addition, and multiplication, so when we go down our list, we didn't have parentheses or exponents, so we did the multiplication before any additions and subtractions. Okay, good. And one of the things I'll recommend is that, I realize that you might feel like you can do this in your head, maybe, I don't know. Don't try and do too many things at one time. That's how you mess these up, all right? Just take your time through it. One line, next line, okay? So, is it Callie? Kaylee? Callie, okay. Callie, what would be the next operation according to our thing over there?
Well, you only have addition, subtraction.
Yep.
So you just work from
Left to right. Okay, so what should I do?
So 5 minus 3 equals 2.
Okay, so 5 minus 3 equals 2, so these two together become 2 plus 576. Callie, go ahead and just finish it out then.
So you add those two, you get
Yep.
578.
578. All right, so that was number 1. That was pretty straightforward, I think. Not a whole lot of stuff. I think number 2 looks a little more interesting, doesn't it? Okay. Number 2. Who's got lucky number 2? Emily. Yes? Emily, what do you see happening here? A lot of parentheses, right? So when you have multiple parentheses, this is important. If you have parentheses over here, addition, subtraction, another parentheses over here, you can work them individually. It doesn't matter which one you do first, all right? But if you have a parentheses and then another parentheses inside of it, you have to start inside. Does that make sense? Like I could do this or I could do this one or this one first. Doesn't matter. But when it comes to this one, I've got to go in here first, all right? So why don't you just tell me what you want me to do and I'll write it down. Which parentheses do you want to work with first? The left one or this right one? The left one? Okay. So Emily, what would this become? If you're going to do this, what would that become? -3, right? 3 take away 6 is -3. But how am I going to write that now? I have 2 plus, there was a 2 here, right? Times -3. So when I write that, I'm going to write 2 and then times -3. Now this is weird, all right, because we have like a dot and then a minus, right? If you forget to put the dot, that's going to look like subtraction, isn't it? So it might be better in this case to actually do the parentheses and that would imply the multiplication, and you would maintain that negative so it doesn't look like subtraction. This is where in math, this little notation things are so important, but you need to understand, like, sometimes people are like, I'm just going to put parentheses to be safe. But no, I mean, that could change the problem. You have to understand when to put them and when not. Are we clear with this? Sure? This is going to be 2 times negative 3. Now, I need to continue writing the rest of the problem, and I'm not going to do anything to what's here. I'm just going to leave it all alone. Okay. Thomas, where's Thomas? How you doing, Thomas? I feel like that seat would be terrible if I were sitting there. Are you okay there, like that? Facing like that? All right, Thomas, what would you recommend I do next? Okay, the right parentheses. Which one? I mean, do you want me to work this? You want me to go inside? Inside? Okay, so what do you want me to do in here?
Find 4 over 2.
Do what?
Find 4 over 2, so that'll be 16.
Oh, you're doing this?
Yeah.
Okay, this is the parentheses, right? This right here? So we cannot do this exponent until we've resolved what's in here.
Okay.
So we need to do 1 take away 4 first, before we can do the squared.
So it'll be -3.
Negative 3. Okay, that's it. That was an operation, right? I'm rewriting everything. Now when I write this negative 3 for the 1 minus 4, should I put in parentheses or not?
Yes.
Yes. Because it's about to be squared, right? And then all of that is being squared. You must be Joseph. Joseph?
Yes.
All right. Okay. I'll give you a moment, but you're the last one here. All right, everyone. We've gone through everything. So that means we get to start over. Since we start over, even if you got called today, you may get called again. All right, give you a moment to look at that. This next step is critical. Leslie. Okay. What do I do next, Leslie? Remember, whatever happens in this room doesn't matter, right? Doesn't matter. I'd rather you just make a mistake, tell me to do the wrong thing, all right? But don't freak out about it. Leslie, what are you thinking? Just tell me what you're thinking. What should we do next?
Keep with the parentheses.
Work within this parentheses, okay? So if I'm working in here, that means I'm looking at 1 plus this squared. What am I going to do then? If you, according to the operations, I have 1 plus this squared. So adding would be here. I'm supposed to do parentheses. I'm working within a parentheses. This means exponents, right? Exponents is powers. So that should come next. This squared, okay? Now, this is the important thing. What is negative 3 squared? Negative 3 squared means negative 3 times negative 3. Right? And a negative times a negative is positive, right? So that should be positive 9. Now, compare that to this. If I wrote negative 3 squared like that, what is that? That's negative 9. Now, that confuses a lot of people. Let me explain why this is negative 9. This is the same as negative 1 times 3 squared. I know that that's weird, but that's what it is. That negative in front is a negative 1, and the square is only on the 3. Without a parentheses, you get a different answer. You get negative 9. But with the parentheses, you get positive 9. This trips people up a lot. So we are doing this case, not this case. So when we do negative 3 squared, it will be positive 9 there. All right? So 2 plus 2 times negative 3 minus parentheses 1 plus 9, all of that squared. Are we okay with that? Emily, you all right with that? Valeria? What would be next? the exponent here. Okay. What are you going to square then? The 9. Okay, but isn't the 9 inside this parentheses with the 1? So we should be working within that parentheses first, right? Within the parentheses, we have to do whatever's in here first. So that's going to be 10. Okay, so this is going to become 2 plus 2 times negative 3 minus, you said 10, right? 10. Now this is one of those cases. See how it's minus 10 squared? So the squaring is only squaring the 10. It's not squaring a negative 10. There's a difference between that and this. Okay. Now go ahead and square it now. This would become what? That'll be my next step. 10 times 10, right? That's what this means, 10 times 10. So 100. All right, we're almost there. Matthew, where's Matthew? Have you followed this up to this point? Okay, you're good? All right, what would come next? What about it? You can't do anything to the negative 3. Like if your whole world is inside there, right? There's nothing you can do to it. So tell me what the operations are. I'm going to move from left to right, Matthew. You tell me what the operations are here. Here? What is that? Right here, between these two. Multiplication. That's really like a dot there, right? And then here? Subtraction. Okay, so what would go first? That's right. We would do that multiplication. We have to do this first. 2 minus 6. Good. 2, and then when you multiply these two together, you get negative 6. So you're supposed to have plus negative 6, right? But we never write that. We just write minus 6. And then you still have minus 100. Okay. Colby. Colby?
Right here.
Oh, there you are, Colby.
I just move on to subtraction.
Yeah, just go subtraction and just go left to right. So what would we get when we do our first subtraction?
So we get negative 4.
-4 and then minus 100. And then put that together, you get negative 104. Negative 104. All right. That one was a little more involved, wasn't it? Okay, lots of places where you can make mistakes. All right, number 3 I'm not going to do. I'll just talk you through it. For this root, you look at it like a parentheses. So you're going to do what's in here first. So what's 5 squared? 25 minus what's 3 squared? 9. So you square. 25 minus 9 is what? 16. So this is just the square root of 16, which is just 4. So when you see square root of 16, that means what number times itself is 16, right? All right. Next one. Leah? 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 Do you know what these bars mean, Leah?
I forget what it's called, but it's like, that's the answer in there is -4, so it would be a positive 4.
+4. So this is the absolute value bars. And what they do is they take whatever's inside and they just make it positive no matter what. So you said that what's in here would become -4?
Yeah, but then absolute value.
And then absolute value would make it +4. Good. So when you see absolute value bars, treat them like parentheses. And that means we can do what's in here first or what's in here first. It's up to us. Right? I can do here first or here. So I'm actually going to do the absolute value of -4 minus 9 times 2 minus 3. So I did what's inside the absolute value first. And now I have to take the absolute value of -4, which Leah just said is 4. So it takes whatever's in here, makes it positive no matter what. And then minus 9 times, now what's in this parentheses? What does that become? 2 minus 3. -1. And notice I left it in parentheses. I could have put a dot there instead, but it's multiplication here. So Cameron? Where's Cameron? Cameron. Multiply, good. This is the multiplication, right? So you're not going to do 4 minus 9. You have to do this times this. Now, Cameron, what's that going to be? I'm a little confused with all these minus signs.
-9, and then the 2 subtractions would add to the addition.
Okay, good. So see that minus sign? Bring it down. So 4 minus. So just ignore that right there and multiply these two together. 9 times -1 is -9, but you already had a minus here, right? So you're going to have a double negative, and when you have a double negative like that, minus minus, it becomes a plus. So 4 plus 9, and that's just 13. Why do we have an order of operations? Does anyone know why we have an order of operations? No? That's right. That way, what if we each made up our own order of operations? Then math would never have the same answers, right? You decide to do yours your way, I decide to do mine my way, and we get completely different results. And that wouldn't be good if you're trying to build bridges and things like that, right? Everyone needs to come up with the same answers. So we all had to agree, we're going to do it this, 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 this. And that's the order. All right. I don't have a whole lot of time to go through all of these. So let's pick 2 more out of the rest, maybe 3. So Samantha, where's Samantha? Can you pick one of those? We've already done the first 4. So pick one of those, Samantha. Number 6? I'm not going to make you do it. Look at that. You got off lucky. All right. But Robert, that's us. That's our name, right? Robert got lucky here. Does that look bad, Robert, to you? Or are you okay with that? Looks pretty bad? Okay, so let's just think about it, all right? When you see, this is just for everyone to understand, when you see a long bar like this, that's division, right? If you have multiple things happening up here and multiple things happening down here, you do those separately. You treat them almost like they create parentheses. So we're going to do everything we see up here and everything we see down there separately. And then we will try and divide them. All right? So Robert, I see 1 plus, and then I have division, right? And I'm supposed to do these separately. So I'm going to help guide you here. You get to choose to do one of those separately. So which one would you like to do? This one or this one? Top or bottom? Bottom? Okay, so what is this turn into? 8. Okay, so that's 2 to the 3rd power. That's 2 times 2 times 2. So that's 1 plus, and then over here, all right, so that's a legal move to do that. Now, Liliana, again, you're going to have to do that numerator now, right? You're going to have to do this now, which means you have to add 2 fractions together. And can you put them, yeah, you're already saying it. You can't do that, right? You have to put a common denominator before you put those together. So if you want to, you could almost look at the numerator as its own little problem over here, right? Like it's its own little animal, and we're going to get an answer, and we're going to plug it back in over here. So what would the common denominator here be? 15? So I've got to multiply the first one by 3 over 3, and the second one by 5 over 5. Thomas, you're back up. Thomas Train.
I have 6 over 15 plus 5 over
6 over 15 plus 5 over 15. Everyone on board with that? And that, when you add them together, would become 11 over 15, right? So I'm going to come back over here now. I'm going to rewrite this as 1 plus 11 over 15 over 8. And this right here is tricky. Pepe? Do you feel comfortable with this right here? What to do with this?
11, 5,
Mm-hmm. Uh-huh. Good. Okay, so I'm going to write down what you said, and then I'm going to help everyone get to that same place. 11 over 5 times 1 over 8. Correct? That's what you said? That's what this becomes. Now let's try and understand this. We have a fraction over non-fraction, but 8 is a fraction, right? It's 8 over 1. So isn't this a fraction divided by a fraction? Same thing? So I'm going to get to this. I could rewrite this right here, again, like little scratch work on the side. I could rewrite that as 11 over 5 divided by 8 over 1. Right? That's what that would mean. 11 over 5 over 8 over 1. Yes?
Wasn't it supposed to be 11 over 15?
Was it 15? Why did I put 5? Yeah, I don't know why I put... Does everyone see that? That should have been a 15 a long time ago. Remember, you got 6 over 15 plus... Who got 6 over 15? Thomas did. Right? And then I just, for some reason, put 5 here. So that's not your fault. That's my fault. This should be a 15, everyone? Okay. Thank you for pointing that out. This should be a 15. It's not going to change anything at this point, right? It's still a fraction over a fraction. Flip it. We good? Okay. All right, now, once you have fraction divided by fraction, you can turn to multiplication of the reciprocal. So 11 over 15, and then flip the other fraction over 1 over 8. And then just go straight across. So 11 over, big number, 120. So here's where we are. At this point, this is equal to 1 plus 11 over 120. We good? Last step. Skylar? It's going to take me a long time, if ever, to learn your name. So if I call you and I'm like looking like this, don't take offense to it. Except Robert. You know, we have the same name, so it's going to be easy. Yes?
I feel like I want to do the 11 over 20 to a mixed number so I can add that in.
You could do that. So you're thinking of changing this to a mixed number? Yeah. Problem is, you can't, because this is smaller than this. So it is, you can't make a mixed number out of it. Can you turn this one into an improper fraction? 1 over 1, right? Okay. So if you turn that to 1 over 1, then to put these together, you would need what? Common denominator, right? So you have to multiply the top and bottom here by 120. Kind of sucks, but that's what you got to do. So 120 on this one, 120 on that one, multiplying the top and bottom, and you should get 120 over 120 plus 1 over 120, 11 over, what's, come on. It's definitely Monday. I'm out of coffee too, totally dry. No excuses. All right, so here, good? 131 over 120. Okay.
Do you want to leave it?
Yes, I do. You can switch it if you want, but I'm okay with that. If it were in a word problem and it was asking like how many pounds of candy, I might want to switch it. But if this is just like an arithmetic thing, just leave it as an improper fraction. We're happy. Okay, good. Michael? Bragoza, last name? Wait, Joseph.
Yes.
What's up? I forgot about you over here. Okay. You get to pick one, but then you get to start it off too. So we just did number 6. Any of these? Don't go all wimpy on me either. Can I say that? It's 2019. Can I say that? Am I going to get in trouble? Don't go all wimpy. Just pick something that looks hard to you, and that way we can get it done. All right? So which one of those looks hard to you? Okay.
I don't want to pick number 10 because we already did like a problem like that.
Okay, I agree. We've already kind of done this, right? Like this?
Yeah.
Yeah, okay.
So number 8.
You want to do 8? Okay. All right, so just call out the operations, all right? So we have,
Division, multiplication, subtraction, exponent, and addition.
okay, so where are we going to start?
Exponent.
Exponent, right? So what would this be?
16.
16, and then you're going to still have the minus, right? Okay, good. So I'm going to write that down. 48 divided by 3 times 2 minus, you said 16, and then just plus the 5, right?
Yes.
You want to keep going? What would you do next?
Division.
This
Yeah, you divide that.
because you're moving left to right. Yes, you had division, multiplication, subtraction, addition. So these are off the table. You have to do either the multiplication or the division first. You're saying division because we're moving left to right. Good. So 48 divided by 3, 16. So this right here together is 16, and we still have what? Times 2, and then minus 16, and then plus 5. Michael? Ragosa? I'm going to let you finish it. I think you're on top of this. What now?
Oh, 16 times 2.
16 times. You're Michael, right? No.
Joseph.
Joseph, sorry. Why did I put Michael back over here? Where'd you go? I lost you. Okay, who cares? Keep going, Joseph.
It's
32
32
minus 16 plus 5. I think you got this, right? Now the subtraction. So 16 again. 21. Does anyone have any questions over that? Okay, I'm going to real quickly just show you what this one would be, all right? Because it looks kind of weird. So see if you follow this. I'm doing here first, that's 6, right? 6 plus 4, 10. This right here is going to become 10. This right here is going to become negative 3. The bottom becomes what? Careful. Is it 1 or negative 1? It's negative 1. Because there's no parentheses around that negative, this is negative 1 on the bottom. Okay, so we have 10 plus negative 3. What's 10 plus negative 3? 7 over negative 1. And that's negative 7. Just wanted to show you. You worked that on your own, but I just want to at least show you how that would kind of work out. Yes?
Sorry, go back to number 8, you lost me. I have the 32 minus 16 plus 5. And then, the second to last step, right there, yeah.
Isn't
That's what I
this
have.
16?
And then, would it not be 32 minus 16 first? Because addition and subtraction, and then you go left to right?
I think I did that, right?
Oh, yeah, okay, so.
Is it
32
16?
minus 16.
Isn't it 16? 32
Oh,
minus
my
16
bad.
is 16.
I did what you did, and I wrote down 6 and not
Okay.
16.
It's money. I mean,
Gotcha. I wanted to
look,
make sure.
please never get the impression that I'm good at arithmetic. Like, when I say arithmetic, like I can do order of operations. I won't make the mistakes of order. I might mess up numbers like subtraction, like in multiplication. I'll screw it up. Who cares? Like, to me, that's not what's important here. The order of operations is important. You know, so this went to this. It was 16. Then they add 5. So, yeah.
Yeah, I wrote down 6 instead of 16.
Yeah. We call those brain farts, and they happen a lot. And on a test, if you work through, and on that last line, you're showing all your work, and I see that you did 32 minus 16 and wrote 6 plus 5 and got 11, I'm going to take off just maybe 1 point because I can't make it. I can't give you a perfect score because someone got it right. But I'm not going to like say, oh, you know? But you got to show me your work. You know? You got to just show me your work. You know, take your time through the steps. All right, order of operations. Oh, there's more. I guess we'll do one more. Give you a second to absorb those. Do y'all feel like you are I'm not going to say completely comfortable with this, but do you feel like you're ready to go try and do the homework on these yet? Yeah? Okay. Tatiana's up again.
But for me to pick,
Go ahead and pick one of these from 11 through 15. Which one of those looks most interesting to you?
I'll go with 11.
11. I had a feeling you might do that. All right. Do you want to discuss what maybe your first step would be for 11?
Well, I was focusing on the parentheses on the
Okay.
side.
Okay, so there's two sets of parentheses there that I see, like two big sets here and here. You want to just start with this one?
Sure.
So what would this inside become?
Now for parentheses, here is it 4 plus negative 6.
4 plus negative 6, that's what that is.
So that would be like -2.
Negative 2. Yep, so that's what I'm going to do now. I'm going to write 3 plus 2, and then I'm supposed to put negative 2 here, right? So I better put it in parentheses because it's implied multiplication right there. So I'm going to put negative 2 here. Okay, so this is 3 plus, that's 3 plus 2. Then that became negative 2. I'm putting in parentheses because that's going to be multiplied. And then plus, Tatiana, do you want to try and do this one? Okay, so what would the inside of this become?
First, I was thinking of the exponent here. So
Okay, do that first. So what?
5 times going to be -4 at first.
Yeah, but because there's a parenthesis around the negative, that means it's going to turn it into positive. Yes. So plus, it'll be plus 4 there, and you have a 1 here. So 1 plus that 4 would be a 5.
Yep.
And I don't need that in parentheses. Why did I not need, this all becomes a 5, right? That's what we're saying. Why do I not need that in parentheses?
There's no like multiplication.
That's right. There's no multiplication in front of it. It's just add this, right? So I can just say plus 5. Okay, good, Tatiana. Savannah?
You're gonna wanna do the
Multiplication. What multiplication?
the 2.
Oh, the 2 times the negative 2. Yeah, that's multiplication, right? So that's going to become negative 4. So how do you want me to write the next line? Tell me how you want me to write it.
So it would be
3. You can just do minus 4. There you go. Then plus 5. Good. So Savannah's saying that because this was going to become a negative 4, when you multiply and you're going to be adding negative 4 is the same as subtracting 4. So just write 3 minus 4 plus 5. And then from here, I think we can get this, right? 4? Let me check something here. Where's my schedule? So this is review. I've said this is review, and I'm taking my time. I hope you can kind of sense that I'm taking my time here. This course will start to pick up a little bit. I think we're good. I think I'm satisfied with that right now. Let's move on. Solving linear equations. So this is a brand new topic. All right? Brand new topic, but I am assuming that you've seen this before at some point. So let's try and understand some things here. I was trying to explain this to my daughter. She's kind of a nerd. I mean, not in a bad way, but she's real. She sets a bar very high for herself, and she's 9 years old, and they're solving linear equations in their math class. But they're doing things like this, like x plus 4 equals 9. Like they're doing that, and they're being asked to solve for x. I'm trying to explain to her. She's like, she looks at that and she says, "Daddy, you know, like, I know the answer is 5 already. Like, I don't need to do anything. I can just look at that and I know the answer is 5." And I said, "Yeah, I agree with you. You know, that's fine." And then, you know, I try and tell her, "Well, what if I do?" I said, now do you know what x is? You know, can you just look at that and tell me what the x would be in order to make that true? And she's like, no. And I said, well, that's what algebra is about. It's about us having a process to get an answer for this without, if we can't just look at it and get the answer. So what is the process, right? And so solving linear equations is all about trying to solve an equation like this with a process that we all follow, right? But ultimately, it's just to know what that x is that would make this true. Like 5 here would make that true. What would make that true? Now, we call it a linear equation. Does anyone know why we call it linear? If you plot this, it would actually not be a line. You need a y in here also. You need x and y to be a line. But you're on the right track. It has to do with the fact that the power on the x is 1. Since that power is 1, we call this a linear equation. It's a linear equation because there's an equal sign. So linear equation. And we're trying to solve it. So does anyone remember what the steps are to solving? You have to get x by itself. Okay? So to solve a linear equation, what the main goal is to isolate x. That means you want to get x all by itself on one side of the equation. That's what you want to do. And if you do that, then you will have solved for x. Now, what are the things that you're allowed to do with an equation? What can you always do? If someone gives you an equation, what can you always do to it? Maybe after I say, was that? You could switch it. You could do that. But do y'all remember we say that you can always, like, you can add something here and add something here, or subtract something here, subtract something here, or multiply something here, multiply something here. So we have this thing where you can do something on both sides of the equation, but you have to do the same thing, right? So it maintains balance. Now there are a set of steps that we can follow for this. The first thing would be to clear all parentheses. On both sides. Did I spell that right? Parentheses.
It's parentheses. So yes.
Yeah, okay. All right, number 2, we clear all the parentheses. Then we collect like terms. I'm giving you the steps. Once we start working through some problems, we'll actually start going through the steps. Let me just put them up here first. Collect like terms, and then we isolate the x. It's basically, in a nutshell, how you solve a linear equation. So let's solve this first one. It's actually crazy. My daughter blows my mind. And I don't even push math on her, okay? I don't push it on her. Everyone thinks, well, you teach math, so I don't. She's always just like, you know the perfect squares, like 1 squared is 1, 2 squared is 4, 3 squared is 9, right? So she's been trying to memorize those, right? And she's up to 23 now. She's got 1 through 23 memorized. She's got perfect cubes memorized up through a lot, like, I don't know, I think through like 8. But she likes to do equations like this now. And the way we do it is at night. This is, I don't know why I'm telling you all this story. I have no idea. At night, we used to play this game when she was real little where she would lay down and I would draw pictures on her back. Like I would draw a bunny or something on her back. And she would have to lay there and guess what I'm drawing, right? And then we moved to letters. So I would draw a letter, okay, these are capital letters. I would draw an A and she'd be like, just by the sense of touch, she would be like trying to. So we're at a point now where I will draw a linear equation on her back and she will tell me the next step. So like she'll be like, okay, draw an